Check, check. What's up, people? I believe everybody is doing great, nice, and absolutely fine. Come on, I just want to know in the live chat if you can hear me and if you can see me. I am actually waiting for your yo, man. 1 second, I just need to check. Am I audible and am I visible to everybody? Yes, we are live exactly. What's up, buddy? Okay. Is everybody doing great? Come on, man, I just need to know. Yes, hi, what's up? It is actually freezing over here in Kashmir, okay? It's very cold outside. So, people, ladies and gentlemen, boys and girls, I welcome you to JEE English Unacademy. Hit the subscribe button if you haven't, okay? As soon as possible, okay? That's great. So, ladies and gentlemen, boys and girls, today we're gonna be exactly talking about that is some of the previous year questions, best previous year questions from the mechanics, okay? What are all the questions that we're gonna be exactly talking about? That's what we will be basically doing it over here. Everybody in the live chat, if you can hear me and if you can see me, drop a thumbs up and all. Okay, that's great. So, people, so we have today that's best of mechanics PYQs, okay? Yes, that's what we're gonna be basically talking about. And ladies and gentlemen, boys and girls, my name is Yawar Manzoor and I'm a JEE physics expert. You can definitely read it out from the screen itself. What I have done so far. Next is, if you people wanna basically join our Telegram channel, so this is the link over here, okay? Because once we are done with the lecture, every single time we drop the notes in our Telegram channel only. So this is the channel link. You can definitely join it as soon as possible. Whatever the important stuff we have, whatever the important information we need to share, we exactly post it in our Telegram channel only. So just join it as soon as possible. That is this JEE English Unacademy. Next, if you people want to learn from the top educators of the country, you are supposed to join this plus and this iconic subscription as soon as possible. Understand? Because there are countries' top educators who teach you over there. If you people want to take your rank to the next level, like we have already proved in JEE Mains and Advance, what Unacademy is known for exactly, okay? So definitely you should go for this one as soon as possible. Understand? So, if you people want to take this plus subscription, what are the benefits that you can exactly get? First of all, you will be getting live classes every single day, okay? So many educators give you the live sessions every single day. You can join those live sessions for sure. Weekly tests. Once you're done with the entire stuff that you have studied for the entire week, afterwards, you need to check your weekly progress. Understand? For example, you have studied for this chapter. Afterwards, you're supposed to give a test, mock test. That's what we call the weekly test in that particular chapter, okay? Structured courses, the courses which have been designed by the top educators of the country will be given to you, okay? And unlimited access. Once you are done with basically in this unlimited access, you will be given the access that you can create your own batch. Even you can select your own personal favorite educators and you can create your own batch. Understand? Completely depends upon you. We have given you the complete full choice over there, okay? And apart from this, you can basically take, if you want to basically take this iconic subscription, you will be getting all the benefits you get in plus and some of the extra benefits as well, okay? That's personal guidance, okay? That's test analysis. That's experts guidelines, study material, study planners, okay? Personal guidance is all about the personal mentorship, okay? If you need any sort of clarifications, if you have any sort of doubts, you can directly ask that educator. He will be guiding you throughout your exam. Understand? Till you have this iconic subscription, okay? So, and once you are done with your test, afterwards you need to analyze your test scores. That comes under this only. And experts guidelines, study material will be sent to you to your doorstep, okay? And next is for how much amount of time you can basically take this plus subscription and this iconic subscription exactly. Understand? You can take this plus subscription for, we say 12 months, 24 months, 18 months, 12 months, 6 months, 3 months exactly. Understand? So this is exactly that you can basically go for. These are the benefits that you can get in this plus subscription, okay? And you can use my code Yawar in order to get the maximum possible discount. Use this code Yawar. And for iconic subscription, you can definitely go for this one, okay? This is the iconic subscription, 24 months, 18 months, 12 months, 6 months. So definitely go for this one as well, okay? Now, these are basically the batches which we have launched recently on Unacademy. These are the batches which we have recently launched on Unacademy. That is, this has started from 20th, 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 27 exactly. Just check it out, okay? Okay, that's great. And next is, people, this is the T20 series, okay? This T20 series is for exactly everybody of you, the people who are appearing for JEE 2022, 2023, and if you get the rank 5000, rank 1, you'll be basically getting the 5000 reward. Accordingly, you can check it and use my code Yawar to enroll in this one as well, okay? Now, okay, that's great, man. Next point exactly over here is, this is what we have done in JEE Advance 2022, 2021, okay? So these are the ranks which we have produced in JEE 2021 Advance. If you people want to basically fall in this category, join Iconic and Plus as soon as possible, okay? You'll be getting the top class mentorship over there as well, okay? Fine. Next we have, now this is one of the important things that you people exactly need to focus on, because see, people keep saying, is there any way we can learn free on Unacademy? We just don't want to pay any sort of money over there. So this is the only way. We say this is nothing but a mega combat, okay? Mega combat. This is Unacademy's biggest, this is country's biggest scholarship test. If you go for this one, you can win up to 4 crore plus scholarship. And this happens, this is a test. This happens on every Sundays, 11 a.m., 60 minutes, and 21 questions, okay? And if you get the rank from 1 to 3, you'll be getting 1 year IIT JEE Plus subscription. From 4 to 10, 75%. From 11, 50%. There are a lot of people who learn free on Unacademy by using this combat only, understand? They give the test, they take the scholarship, and then they basically go for this one, okay? Now, over here, ladies and gentlemen, we have the question number 1 exactly. That's from the momentum and collisions, okay? So definitely you should go for this one. I want you people to follow this from your end only. Can you guys follow this one? Come on, everybody. Can you follow this one? I'm just gonna give you some time. I want you people to basically follow this one. This is from momentum and collisions exactly. This is from momentum and collisions exactly. All of you, everybody, can you follow this one exactly? Come on, everyone. Okay, so people over here, I just want to basically focus on this question, okay? I want you people to basically go for this one. This was asked in JEE Mains 2021, okay? This is the question from JEE Mains 2021 exactly. Now, I want you people to exactly focus on this one, okay? Solo this question. Now see, what is the question exactly saying? So the question is exactly saying over here, we have a mass exactly that is 10 kgs, okay? This is a mass of 10 kgs exactly, okay? This is a mass of 10 kgs exactly, understand? This is moving with some initial velocity. It is moving with some velocity, I would say, for example, something, okay? I call that, for example, u. This is the initial velocity that this mass is exactly moving over here, understand? Now, the second point over here is, it is saying that there is another mass which is exactly placed in front of this one. So this mass is how much? It is saying that this is 20 kgs mass exactly over here, which is exactly at rest, understand? This is exactly at rest, understand? So afterwards, when they basically, when the collision happens, this is at rest, this mass is motion. This ball is basically in at This ball is exactly at rest. The second ball is exactly at rest. The first ball is basically in motion. So this ball comes and this hits this mass. Afterwards, what happens? It's saying that this first mass basically comes to rest. This 10 kg mass, this 10 kg exactly comes to rest. Understand? And this another one basically splits into two different parts. Understand? So first one, I'll just make it over here. So first one basically starts moving in this direction, okay, with some velocity, and the second one basically starts moving in this direction, something like this. Understand? This is the another one which starts moving something like this. Okay, so basically what happens, I'm talking about the second mass. Understand? Some of the mass has basically, this has been basically split into two parts. Okay, so in that case we are supposed to basically tell at what angle basically this has moved. Okay, yeah, pieces after collision. Yes. So what is the value of this theta exactly that we need to exactly talk about? Okay, can you just tell me what is the answer of this question? Everybody over here, okay? Okay, all of you, with what velocity we are supposed to find, at what angle basically this is supposed to basically move in this direction? That is what we are supposed to calculate over here. Understand? Everybody over here, it is saying that this is having the velocity of, I say for example, this is v1 and this is 10 meter per second, and this is having the velocity of, I say v2 is equal to 20 meter per second. Okay, just conserve the momentum in y direction, you will get the answer of this question. That's all. Understand? Everybody? Okay, fine, all of you. Now see how exactly we can solve this question. I want everybody of you to basically focus on this one. Listen to me very carefully. Now see, if we talk about this mass exactly, understand, if we talk about this mass, can you just tell me over here what is the momentum along y direction initially? Can I conserve the momentum in this case? Definitely yes, I can conserve the momentum. See, can I say in this case F external is basically 0, 100%. See, this is applying the force on this one. Understand? If this mass is applying the force on this one, so that is the internal force. So there is no external force that is coming to this one. Understand? That's acting on the system. If net external force in this case is 0, so we say this F external is nothing but that is dp by this dt according to Newton's second law. If this external force on this system is basically 0, so can I say that this dp will be exactly 0, because this is 0, dt into this 0, so dt will be 0, dp will be 0. What is dp? This is F external is equal to rate of change of momentum with time according to Newton's second law, rate of change of momentum with time. So can I say momentum initial is equal to momentum final? If dp is 0, means change in momentum is 0. So that in that case we say initial momentum is equal to final momentum. Now, if momentum initial is equal to momentum final, can we conserve the momentum over here? I want you people to basically conserve the momentum along y only. Okay, conserve the momentum along y only. Understand? Y direction, you will get the answer. So you tell me one thing. Initially momentum in y direction is 0. Why? Because this mass is basically moving in x direction only. This is at rest. So this is having the momentum of how much? You will say, sir, mv. And this is having the momentum of how much? You will say, sir, 0. So this is entirely the initial momentum is basically along x. So can I say p initial is basically 0? And in this case we say momentum is conserved. Initial momentum is equal to final momentum. So final momentum has to be along y only. Understand? So we say finally the momentum is basically what? You say, sir, this is having the momentum 0. And what about this mass? This will be having some momentum. This will be having some momentum. So how much momentum this is having? You'll say, sir, this is having momentum, that is m, and this will be v1 exactly. Can we say how much this will be having exactly momentum? You'll say, sir, this will be exactly having, this mass will be exactly having momentum, that is nothing but m v2. And can I say if this is v2 along this one, can I say this will be v2 cos of theta, and this component will be v2 sine of theta 100%. Now see, I'm saying this is the velocity this is the cos component and this is the y component. We are supposed to conserve the momentum along y, so we are supposed to take this component and this one momentum along y. So can you tell me finally how much will be the momentum? You'll say, sir, finally momentum will be exactly, p final will be exactly, you'll say, sir, that is mv1 in the upward direction. So can I just write this will be mv1, okay? And this will be plus this mv2 sine of theta, because velocity in the downward direction is nothing but v2 sine of theta, okay? Once again, what? I'll tell you afterwards. Okay, let me just solve this one. So we say v2 sine of theta. We say v2 sine of theta. Now, upward velocity you are taking as positive. Downward velocity we can take as negative. We are supposed to take, if you say, for example, the body is moving in right direction. So we take this velocity as positive. Understand? Body is moving in left direction. We take that velocity as negative. Same is the case over here. So we say this is nothing but mv2 and this will be exactly sine of theta. Okay. Mass is exactly same. So we say if initial momentum is 0, final momentum has to be 0 exactly, because external force in the entire case is basically 0. So we say this has to be exactly 0. So mv1 minus mv2 sine of theta will be exactly 0. Can I say it like that? So just take it over there. So we say basically in this case, cancel this one. So this will be v1 is equal to v2. This is sine of this theta. Can I say sine of this theta will be exactly v1 by v2? What is the value of this v1? You'll say, sir, that is 10. v2 is, that is 20. So that is this 10 upon this 20. So this will be 1 by 2. Theta will be exactly 30 degrees. Okay. ये v2 20 meter per second है. So ये theta है 30 degrees. Okay. Fine. Everybody got the feel of this one. Let me just make you understand this once again. We have this mass. This is moving with some velocity. There is this mass which is exactly at rest. Understand? This mass is hitting this mass. Understand? Afterwards, after collision, okay, afterwards, when collision happens, afterwards, the first mass comes to rest. Understand? So when first mass comes to rest, it's transferring its all of its क्या नाम है इसका velocity to this second mass. This second mass, half of it is basically going in upward direction. Half of it is basically going in this direction, making an angle theta with the x-axis. Understand? This is the case. We are supposed to find at how much amount of angle it is making with the x-axis, this one. Understand? So that is the question. So we are conserving the momentum over here. We say initial momentum is equal to final momentum. We are conserving the momentum along y direction only because that's going to give us the answer exactly. So we say initially momentum along y is 0 because mass is moving in x direction only. So we say initially momentum is along 0. Along y is 0. So finally it has to be 0 only. So finally this is the momentum along y direction because of this mass onto velocity. Because of this mass, this is the momentum along this y direction. So that's what I exactly did over here. This is the calculation and that's all. Let's move on to the next question. This was asked in JEE Mains 2020 exactly. Okay. Come on. Solve this question. I want all of you to basically go for it. It is not that difficult. It is very simple. Very simple, brothers and sisters. So let me just make you understand what this question is all about over here only. Over here only. See, it is saying that we have exactly, there is this table, okay? There is this mass is resting, okay, on a height of h, okay, okay. So what exactly is happening over here? See, we have, this is a height exactly, understand? This is some height, I would say 1 meters exactly. This is given as 1 meters, okay? This is 1 meter height. There is this bullet, understand? We have fired this bullet. The mass of this bullet is exactly how much? It'll say, sir, 0 kitna hai? 0.1 kgs, okay? 0.1 kgs, okay? And this is moving with some velocity of that is 20 meter per second. 20 meter per second. This is moving with some velocity. And there is a box over here. There is a box exactly over here placed on this one. This is the box exactly. Understand? This is the box. This bullet is basically, this box is exactly at a rest. The mass of this box is exactly how much? That is 1.9 kgs. 1.9 kgs. Okay. 1.9 kgs. Okay. So this is the situation that is happening over here. Let me just make you understand this. So afterwards, this bullet is basically moving with 20 meter per second. There is this block which is exactly at rest at the height of 1 meter. This block, this mass is, this bullet is basically hitting this mass. It is entering this block. Afterwards, the situation is something like this, okay? The situation is basically something like this. So I'll just make it over here. Bullet is now inside this one. When this bullet inside enters this block, afterwards, this starts falling with a, this starts horizontal velocity over here is 1 meter per second. And this starts falling something like this. We are supposed to find how much will be its kinetic energy when it is about to strike the floor. Okay, kinetic energy over here, kinetic energy final. I'll just write it over here. Okay, This is the question. I hope everybody got this one. We have a block over here, okay, that is at h height. This bullet is coming towards the block. This block is exactly at rest. This is moving with a velocity of 20 meters per second. It is entering this block. Afterwards, block and this bullet, because this bullet is entering this block and stays over there, both basically starts falling down. So this system now starts moving with velocity 1 meter per second. And we are supposed to find when this block will exactly hit the ground at that point of time, how much will be exactly its kinetic energy final. That's what we are supposed to do exactly. Understand? All of you, I want you people to solve this at your own. Come on, everybody. Everybody, come on, all of you. Okay? Can you solve this question? Mains 2020. Mains 2020. It's a very simple question. First of all, I suggest you to basically conserve the momentum in this case. Now see, we say over here, external force is basically zero. Whatever happens between this mass and this mass, that is the internal forces, okay? Collisions ka maamla hai. Okay, we say in this case, if external force is basically zero, in that case, if we use the Newton's second law, if external is basically, that is nothing but this dp by this dt, rate of change of momentum. Understand? This is what we call, what is this rate of change of momentum? This is Newton's second law, okay? Exact Newton's second law. 100% correct, everybody, okay? Okay, yes, first conserve the momentum, then conserve the energy. You can definitely go for it one. Okay, everybody. So we say over here, can I say external force in this case is zero? Definitely. If external force in this case is zero between this and this, so can I say in that case, dp will be exactly zero. Change in momentum will be zero. Put it zero over here. Momentum will not change. Understand? When there is external force, momentum changes. Understand? Because Newton's second law says rate of change of linear momentum with time is force. More you apply force, more the velocity of the body changes, more will be change in momentum. Understand? This I have explained in Newton's laws of motion in complete detail. So we say change in momentum in that case is zero. If change in momentum over here is basically zero, can I say momentum initial is equal to momentum final? I can simply say, okay. Can you tell me how much is the momentum initially and how much is the momentum finally in this case? You'll say, sir, momentum initially is only because of this mass, because of this bullet, because this is moving, this is at rest. Whenever there is mass and there is velocity, we say there is momentum. So because of this one, it is zero, because this is at rest, velocity is zero. So this is contributing to momentum initially. Afterwards, when this bullet will enter this one, when they hit each other, afterwards, what's going to happen? You will say, sir, this system will have momentum finally. So if we conserve the momentum, initially, if I talk about, you will say, sir, that is mu plus this will be zero is equal to finally, that is m plus this m, and this will be exactly this v. Samajh aaya kya kiya? Initially, momentum is because of this one only. Understand? This is zero. Finally, momentum is because of both. Understand? Both starts moving, falling down. This starts, the horizontal velocity over here is how much? That is 1 meter per second. That I'll get after some time. How exactly we got this one? Okay. So how much is the momentum over here? You'll say, sir, momentum over here. See, we are supposed to find the final kinetic energy. For that, we are supposed to find this velocity over here. Isko abhi bhul jao, theek hai? We are supposed to find this velocity over here. We'll apply the conservation of energy. Then that's why I'm finding the velocity at this point of time. Okay, chalo. So kya main likh sakta hu? Can I basically write it over here? This will be exactly, that is, this is 0.1 multiplied by this 20 will be exactly, this is 0.1 plus 1.9. This will be exactly V. You get 2 and this exactly yahan se V will come out to be 1 meter per second. Okay. So when I got the velocity of this mass over here, V is what? That is final velocity. With what velocity it starts moving in the forward direction? So V is equal to 1 meter per second. Okay. Now apply the conservation of energy. Okay. Just 1 second. Okay. Now apply the conservation of energy. You will say, sir, kinetic energy final plus potential, kinetic energy initial, potential energy initial is equal to, that is nothing but, okay. So we say it will be exactly, that is Kf plus this is Uf. Okay. Can I just say it something like that? Okay. Everybody. Okay. Okay. You people want the relaxation? Okay. Sir, please support extra attempt in JEE Advanced 2022 with you people only. Okay, chill scenes. Full support. Okay, okay. So just put it over here. Definitely, we can definitely put it over here in that case. So how much is the kinetic energy initial in this case? Can you just tell me? So we are supposed to basically use, in this one, we'll use basically the conservation of energy in this case. Kinetic energy initial, you will say, sir, that is 1 by 2 mv square. And it will be having potential energy as well. Understand? So then apply in this one, 1 by 2 mv square. 1 by 2, m is how much? You'll say m of this one is basically the total one exactly. Understand? Then potential energy at this 1 meter height. Over here, you'll say, sir, final kinetic energy we are supposed to find. And this will be exactly at this point, potential energy will be 0. Come on, I just want to know the answer in the live chat itself, okay? Sir, video band dijiye please, matlab? I don't get it, man. What are you saying? Come on, all of you. So, can I just write over here how much it will be? You will simply say, sir, 1 by 2, this is multiplied by 2, 1 by 2 m and v square, that is 1 exactly. Can I just write it like that? And this will be potential energy. How much is the potential energy in that case? That is m plus m. See over here, mgh, we say mgh. Understand, this will be m plus this m exactly. So how much that will be? Come on, all of you over here, can you just tell me? So we say simply that is nothing but this is m plus this m. Understand? And this is gh. And this will be kinetic energy final, and this will be exactly 0. Potential energy finally is 0. Kinetic energy finally when it is about to hit the ground. At that point of time, we are supposed to find its kinetic energy, that is final. Understand? So first we have used conservation of linear momentum. Afterwards, we used conservation of energy. That is the entire case over here. Understand? Put up the values in this case. This will be 1 plus, this will be 2 exactly over here. Understand? So 2 into 10 into 10. So this will exactly cancel. So this will be 1. From this side, this will be exactly how much? This will be 2 into this is 10 into this is 1 is equal to this is kf. So ye ho gaya 20 plus 1. So kf will come out to be, that is nothing but 21 joules after putting up the values. So can I say this is the correct answer? Yes. Okay. Come on, let's go for the next one. Okay, okay. So, can you solve this question? Sir, please make a dedicated video supporting extra attempt for JEE Advanced just for rural area students. I'll try to make a video on this one. Don't worry about that. Chill scenes, bro. Come on, everybody. Can you solve this question? Everybody of you. I'm with you people, okay? Chill scenes. Now, we have this question on the screen. Can you just solve it? Mains 2019 exactly. This was asked in Mains 2019 exactly, okay? So I'll just make a figure over here. How does it exactly look like? So it'll be something like this only, okay? So there is a block on this floor exactly. This is a block over here. I'll just try to make the block, okay? This is a block. Kitna hai? That is 10 kgs, okay? This is 10 kgs block, okay? And this is the force that is acting on this one, that is 3 newtons, okay? From this side. And from the upper side, this is the force that is F is acting over here. And this is a friction over, friction is also static friction between this and this is given, that is 0.6. We are supposed to find how much amount of force this should be. What should be the minimum value of this force so that the block should not fall down? This is given as 45 degrees, okay? This is inclined plane is 45 degrees exactly. What should be the value of this F so that the block should not basically fall down? Understand? So that the block should not. Just you balance the forces, okay? Equilibrium of forces. That is the concept that you people need to use over here. You'll get done with this question, okay? You'll get the answer of this question. That's all. Come on. And everybody like the video as soon as possible. Mark the attendance. Can you guys solo this as soon as possible? Come on, make the FBD. That's all what you are supposed to do in this case, okay? You'll say, sir, what should be the minimum value of this force so that the block should not basically fall down. Understand? So that the block should not skid. So means the block has to be in the rest only. That should be, if that is the value of force. Understand? So we don't want this block to basically skid down, fall down. So we say downward forces has to be equal to the upward forces. In that case, the block will exactly not fall down. Can I say it something like that? So just draw the forces over here. Can I say in the downward direction, this will be exactly, that is 10G. This is sine of theta. Understand? Sine of 45. Okay. Okay. Sorry, cos of 45. Arey, kya kar raha hu yaar? If this is theta, this will be exactly theta. Okay. So 10G, this will be exactly cos of 45 yahan se. And this component will be exactly, this will be exactly 10G cos of 45. This is 45. This is 45. This will be exactly 10G sine of 45. इसको लिखता हूं इस वाले कलर से. इसको लिखता हूं इस one. That is 10G yahan se sine of 45. Okay. And over here, can I say friction will exactly act? 100% friction will exactly act from this side. Now you just tell me one thing. If we basically yahan se ho gaya iska normal reaction. Now make the FBD of this one. Can we just make the FBD of this one? You'll say, sir, this is the force exactly. Sir, this is the block exactly over here. And in the upward direction, normal force is acting. In the downward direction, 10G cos of 45 is exactly acting. Okay. And from this side, this F is acting. And this is the frictional force which is acting. We say this is the static friction exactly over here. And from the right side, 3 Newton is exactly acting. और क्या यहां से ये हो गया 10G sine of 45 exactly. Okay. Now balance the forces. From over here, can we just write this N is equal, upward force is equal downward force. Okay. We don't want block to basically skid down. Okay. So can we say this N will be exactly in that case, that is 10G. This is cos of, this is 45 degrees. Okay. Very simple. And leftward forces are equal to the rightward forces in that case. So I can simply say, sir, this F plus this F, understand this F, these forces should be, has to be equal to this one. Then only the block will not exactly skid down. It will be exactly equal to, that is 3 plus this is 10G sine of 45 degrees. Okay. Can we just say it like that? 100%. Ab let's basically go on to the next slide. So a kaam karo, can I just write this second equation? Can I just write F plus, this is mu times of this N. इसके बदले में I'm just writing mu times of N. Understand? So it will be exactly equal to 3 plus 10G sine of 45. That is 3 plus 10G sine of 45 degrees. Okay? Okay? This exactly. Now, can I just write, see, if we got over here, that is nothing but mu times of N. What is the value of N, normal force over here? Let's say, sir, upward force. If we say friction is equal to mu times of N, mu s times of N over here. Okay. So can we just put it over here, everybody? Come on. Give me a thumbs up if you're understanding this one. So can I just write this is F plus and this is mu as it is. Okay. This is mu. And instead of this N, can I just write this is 10G. This will be cos of 45 degrees. Okay. This will be exactly equal to, that is 3 plus this is 10G and this is sine of 45 degrees. I can simply say it like that. I hope there is no confusion in this one. Okay. Everybody. So this F will be exactly as it is. Okay. We are supposed to find this F only, plus this mu is 0.6. I can write 6 by 10 exactly, multiplied by this 10. G is equal 10 meter per second square. Cos 45, I guess 1 by root 2, not sure. Okay. You just find it. Okay. 3 plus this is 10 into this 10 sine 45, 1 by root 2. Come on. Can you just follow this now? Yeah. So can I just write this F will be exactly equal to, this is 60 plus 60 by this root 2. And this will be exactly, this is 3 plus this 100 by root 2. Very simple concept that I'm exactly using over here. Okay. 3 plus 100 by root 2. So what exactly I'm trying to say over here is, this is 60 by root 2. Take it over there. This is 100 minus 60 by root 2. 40 by root 2 exactly. So F will come out to be, that is 31 newtons. Okay. This is the answer. Keep this answer in your box. Okay. This is the answer exactly that we got. 31 newtons. Option number A is the correct option. How many of you got this, man? Okay, fine. Just upward force. See, it is saying that how much, what should be the value of this force so that the block should not skid down. Understand? So means in that case, the block has to be in the equilibrium. It has to remain in equilibrium. Understand? So means these forces has to be equal to these forces. Upward forces is equal downward forces. Okay? अरे ऊपर नीचे तो motion हो नहीं रहा फिर भी I'm saying okay. Fine. Next question on the screen, JEE Mains 2021. Can you just follow this one? Okay. Everybody, I want you to basically solve this as soon as possible. Come on, man. Can you solve this question? Can you solve this question? Okay. So we have this question exactly on the screen. That's what I need. I want you people to basically answer this question. Okay. Fine. I want you people to exactly answer this question. Okay. A swimmer can swim with a velocity of 12 km per hour in a still water. Water flowing in the river has velocity of 6 km per hour. The direction of, with respect to the direction of the flow of the river, water should swim in order to reach the opposite. Tick. See, listen to me very carefully what exactly the question is saying. It is saying that, for example, we have, this is a river over here, okay? This river. So, swimmer can swim with a velocity of swimmer is nothing but how much? It is saying that 12 km per hour. So, swimmer can swim with a velocity of 12 km per hour. It is saying that at what angle the swimmer should basically swim, at what angle the swimmer should basically swim with respect to the flow, so that he will travel in the straight direction and reach exactly opposite point. Understand? Exactly up. He should travel straight. Understand? So at what angle he should basically move? Vs. Okay, at what angle? So you will say, sir, this angle. Am I talking about this angle? Am I talking about this angle? Definitely not. Definitely not. Understand? Keep this thing in your mind. I am talking about this total angle, this angle exactly. Understand? So this angle we are supposed to find. Understand? This is velocity of, we are supposed to find the direction with, what should be the direction of this swimmer with respect to the flow. What is the direction of the flow? You will say, sir, direction of the flow is this. That is velocity of river. Understand? How much is velocity of river? You will say, sir, velocity of river is nothing but that is this 6 km per hour is exactly given over here. Understand? And velocity of swimmer this. Understand? Fine. So at what angle this swimmer should basically swim with respect to this flow, so that he travels from this point to this point in a straight direction. Say theta is equal to 30 degree, 50 degree, 120 degree, 90 degree. Most of the people will say 30 degree. That is incorrect. Okay. Let me just make you understand over here. So can I say this is Vs? This Vs will have two components. If we say, for example, this is theta. So this Vs will exactly have two components. So we say this will be exactly, that is Vs. If this is theta, this will be Vs sine of theta. And this will be exactly, this component will be Vs cos of theta. Can we say it like that? 100%. Now, if the swimmer has to travel from this point to this point in a straight direction, means in that case, this velocity has to be equal to this velocity. This velocity has to be equal to this velocity. This velocity has to be equal to this velocity. Understand? I hope you have studied this case in river swimmer problem, that whenever the swimmer has to travel straight, understand, like this, understand, in a straight direction, the shortest possible path, this is what we call the shortest possible path. In that case, it's one of its velocity, like one of the components of its velocity has to kill this velocity of river. See, what exactly I'm trying to say, that if you travel, for example, something like this, there is the velocity of river. So this velocity will drag you towards itself. Understand? So you will eventually reach over here. But what is the questioner saying? That the person has to reach exactly the opposite one. So this person has to exactly travel at some angle initially. Even if he drags, he will exactly reach over here. There will be no drag exactly over here. Keep that thing in your mind. So he will exactly travel through this one. But initially he has to go at some angle. Understand? Because the velocity, one of its components of velocity, v sine theta, has to kill this velocity. When this velocity kills this velocity, so now he will travel with the net velocity, that is v cos of theta, through this one only. Now in this case, when the person travels straight like this, something like this, in that case, can I say this velocity has to be equal to this velocity? So we say Vr is equal to, that is Vs sine of theta. Can I say it like that? How much is the value of Vr? You will say, sir, that is 6. This is 6 is equal to, you will say, sir, Vs, that is 12. and this is sine of theta. So can I say this is sine of theta will be exactly 1 by 2. So theta is equal to 30 degrees. Is this theta is equal to 30 degrees correct? Definitely not. This is incorrect. We are supposed to find this angle. Theta is this. Understand? We are supposed to find this angle alpha. So can I say alpha will be exactly, that is this 90 plus this theta. So that will be 120 exactly. Okay. So this with respect to flow, understand this total angle. So 120 is the correct answer in this one. I hope you got it, man. This was asked in JEE Mains 2021. Now we have this JEE Mains 2019 question. Can you solve this question, all of you? If you can solve this, just solve it as soon as possible. ASAP, brothers and sisters. Okay. Can you just solve this? I want you to basically solve this as soon as possible. ASAP. Okay. What is the correct option? A, B, C, D. A, B, C, D. Which option is correct over here? A, B, C, D. Come on. Let me just make you understand. See, the position of a particle as a function of time t. So we are given as a displacement over here, the position of the particle. This is some sort of displacement time relation exactly over here. That is, this is given as, that is x is equal to, that is nothing but, this is at plus this bt square minus ct cube exactly. So this is the relation that we exactly have got over here. So what exactly I am trying to say is that we are supposed to find when the particle attains zero acceleration, then its velocity be. Suppose there is this particle, understand, that is moving. So this is the displacement time relation. It is saying that it will be having some velocity. When this particle attains, when it has zero acceleration, when its acceleration becomes exactly zero, what will be the velocity at that point of time? That is what we are supposed to find. This car is basically moving something like this, understand? So for example, at some point of time, its velocity acceleration becomes zero. At that point of time, check its velocity. So that velocity we are supposed to calculate in this one. How much is its velocity when it attains zero acceleration? Come on. If you can solve this one, come on, let me know in the live chat. How much will be exactly its velocity in that case? Okay, when it attains zero acceleration. When it attains zero acceleration, tell me the velocity. Tell me. Okay, come on. Can you solve this? So first of all, you just try to find out the velocity over here. You'll say, sir, velocity is nothing but that is dx by this dt simply. Very simple, velocity is dx by dt. So can I just write in that case, this will be a, this will be plus 2bt. Can I just simply, this will be 2bt. Differentiation of this one, that is nothing but a only. With respect to t, I am doing. That is 2bt minus 3ct square. Okay, this is the velocity. Now, can you find the acceleration from here? You'll say acceleration is nothing but that is this dv by this dt, we can simply say. So how much is acceleration? You'll say, sir, that is nothing but iska 0 ho jayega. So can I say this will be 2b minus this will be exactly 6c. This will be exactly that is 6ct. Okay, this came out to be the acceleration over here. Now see, we'll put this acceleration equal to 0 and we'll check the time at that point of time. I'll just tell you. So put this acceleration is equal to 0. Understand? See, it is saying that when particle attains zero acceleration, then at that point of time, what is the value of velocity? See, we'll find when acceleration is 0, what is the time at that time? Hey, you getting me? So find the time over here. You'll say 2b is equal to 6ct. You'll say t is equal to that is 6. This 2b. अरे किधर गया यार? एक सेकेंड. इसको इधर कैंसिल करो. ये है 3 से हो जाएगा. क्या मैं लिख सकता हूं? That is b by this will be exactly 3c. 100%. So can I say that? See, acceleration, we put acceleration is equal to 0. Means at this time, acceleration is 0. If we find at this time, what is the value of velocity? So that means we got the answer of our question means at that point of time, the velocity will have zero acceleration and we'll get the velocity at that point of time. Understand? See, at this time, the acceleration is basically 0. So we say at this time only we'll find the velocity. That is the question exactly. Na? In question, it is asking that when particle attains zero acceleration, what will be the value of velocity? Okay, so we'll find the time when acceleration is 0. On this time only, we'll find the velocity. That is the answer of our question. So now, let's basically find that only, okay? Let me use this color. Okay. So just put this in this velocity term, okay, over here. I'll just write it over here. So can I say this velocity is how much? You'll say, sir, that is nothing but a plus 2bt minus 3ct square. A plus 2bt minus 3ct square. A plus 2bt minus 3ct square. Put the t value of t in this case. So AV is equal to, that is this A plus 2B, and what is the value of this time? That is B by 3C. B by 3C minus 3C into B square by, this is 9C square exactly. So V is equal to A plus, this will be exactly 2B square by 3C minus 3 1s, 3 3s, C and this C. It will be exactly, that is B square by 3C. This is 2B square by 3C minus B square by 3C. So how much it will be? V is equal to A plus B square by 3C. This is exactly the answer in that case. कौन किधर गया? A plus B square by 3C. A plus B square by 3C. Option B is the correct option. I hope you got it, man. Come on, let's move on to the next one. Okay. Find the tension at the midpoint of the rod. This is one of the beautiful questions in the entire session. Okay, I want you people to basically solve this one from your end only. It is something like this, okay? There is this block, okay? This block is basically attached to another block, okay? Okay, this is exactly 2 kgs. This is exactly 4 kgs, okay? This is 2 kgs, this is 4 kgs, and the force acting on this is 100 Newton. This is 100 Newton, okay, in the upward direction. We are supposed to find the mass is basically massless, okay? The rod is not massless, understand? So we are supposed to find the tension at this point, tension at this point, tension at this point, okay? Can you guys tell me what is the answer of this question in the live chat? Do let me know. चलो बोलो इसको क्या करें हम? Come on, people, solve this from your end only. What's the time? Solve this from your end only. Now see, if I talk about this mass, see, I need to find the tension at this point. You'll say, sir, tension will be same. When there is a massless string, massless rod, in that case, we say tension is same. So there is, this is having the mass, understand? So tension will be different at this point, at this point, at this point. Let me just make you understand how we can exactly find the tension. First of all, you try to find out the acceleration of this entire system. How you can find the acceleration of this entire system? You say, sir, acceleration will be exactly, that is what? Net force, net pulling force upon net mass. That is net pulling force upon net mass. Net pulling force upon net mass, okay? Can we say acceleration will be something like this? You'll say, sir, net pulling force in the upward direction, that is 100 Newton, okay? In the downward direction, what is the force acting? You'll say, sir, on this one, this is nothing but 2g, mass into acceleration due to gravity. In this direction, you'll say nothing but 4g. On this rod, mass of the rod is 2 kg. So on this rod, I'll just show it, that is nothing but 2g exactly. Something like this, okay? Keep this in your mind. So I can simply write, this is 100 minus 2g minus 4g minus again 2g, okay? Upon how much? Net mass. What is the net mass of this one? 4 plus 2 plus 2. That is 6, that is 8 exactly. So this will be exactly 100 minus 80 by 8. 100, this is 20 by 8. That will be 2.5 meter per second square. 2.5 meter per second square, okay? 2.5 meter per second square, okay? This came out to be the acceleration. Now listen to me very carefully. Now, if I ask you to tell me the tension at this point, if I say, for example, this is TA, this is TB, and this is TC, we are supposed to find at all the 3 points over here. Okay. Now, tension at this point, take this block 1, take this block 2. Okay, take this block. Understand, take this block. That is 4 kg block. This is 4 kg block. We say this is the rod. At this point, tension will be, that is nothing but TA. Okay. At this point, tension will be TA. Now, apply the Newton's second law on this rod. So we say in the downward direction, 4G is acting. On this rod, how much? You will say, sir, 2G is acting, because the rod is having, we are taking the entire rod. That's what? Till TA. Understand, the upper point. So can I say Newton's, after using the Newton's second law, in that case, you will say net force is equal to mass times of acceleration. TA minus 4G minus 2G is equal to mass times of acceleration, net mass. That is 4 plus 2 is 6. So 6 into acceleration, that is 2.5 exactly. So this will be 60. And this is how much? 15. This is 15. This is 60. Total will be, TA will be nothing but that is 75 newtons. So at this point, tension acting will be 75 newtons. Similarly, you can find the tension at this point B. So we can basically find the tension at point B. So tension at point B exactly. How can we find the tension at point B? Listen to me very carefully. If I talk about this point B, so take this mass exactly. So you will say, sir, if I take this mass over here, okay, so this is 4 kgs, and I'm talking about this point only. This is TB, okay. So in the downward direction, 4G will act, and on this mass, on this rod, what is the force that is acting in the downward direction? You will say, sir, that is 1G only, because I'm taking half of the rod only. Understand? So apply. You will say, sir, in this case, net for F net is equal to mass times of acceleration. So how much? We'll say, sir, TB minus 4G minus 1G is equal to mass times of acceleration. That is 5 into 2.5 exactly. Come on. So T2 will come out to be, TB will come out to be 60 newtons exactly. Okay. ये हो गया तुम्हारा 60 newtons. Fine. I hope everybody is able to understand this one. Come on, all of you in the live chat, if you can understand this one, if you got it, let me know exactly. Okay. Okay, man. Fine. So this will be exactly T. ये हो गया 40. This is 40 this is 50. 50 इधर लेके जाओ, 62.5 आएगा. Check it. Okay, it will come out to be 62.5 exactly. 62.5 newtons. ठीक है. अब tension at C. Tension at this C. At this point C, we are supposed to find the tension. Take this block only. Once again, take the same block. Okay. This is 4 kgs. In the downward direction, 4G is acting at this point of time. So there is no rod. Understand? So can I say T is equal to, that is nothing but MA. TC is equal to MA. So this will be exactly mass of this one 4 into this will be exactly how much? Acceleration, that is 2.5 exactly 4G. Mass into acceleration, sorry. This will be exactly how much? अरे क्या गलत किया मैंने? TC is ये. हाँ. Yes, exactly. So this is exactly, I'm taking this point TC. Understand? This is TC and this is how much? This is 4G. TC minus 4G into mass times of acceleration. So can I say TC will be come out to be 50 newtons in that case by using the same formula exactly. Let's go for the next one. On the same concept, a question was asked in JEE Mains 2013. Let me make you understand what was the question exactly that was asked in JEE Mains 2013. Listen to me very carefully. We have exactly a mass, okay? We have exactly this mass and we have exactly this mass, okay? So a mass of M1 is equal to 20 kg. This is 20 kgs, okay? And M2 is equal to 12 kgs. This is 12 kgs exactly, okay? And there is connected to a metal rod of, this is 8 kgs, okay? This is 8 kgs. And the force is acting on this one 480 newtons in the upward direction, okay? 480 newtons. The tension at the midpoint of the string, can you tell me how much is that net pulling force? You will say, sir, that is 480 newtons, okay? 480 newtons minus What is the force in downward direction? Because of this one, you'll say, sir, that is 20G. Minus because of this one, this is 8G. Minus because of this one, this is 12G. What has happened to my internet, man? Yes, yes, yes. There was a lag actually. Now I guess it's fine. Okay, people, just have a look over here. Okay, yeah, now it's fine. Now we are supposed to find, we got the acceleration. Take this block 12 kgs. Exactly, this is 12 kgs. Okay, in the downward direction, 12 kg, 12G is acting. At this point, we are supposed to find the tension. Half of the distance, understand? So we'll have to take 8 kg, 4 kg only. So this is the tension. Now apply the Newton's second law. This is T minus 12G minus this 4G exactly is equal to mass times of acceleration. That is 16 multiplied by 2 is 32. So T will come out to be 192 Newtons. Okay, after solving this one. So 192 Newtons. Okay. Okay, so this was all about it, ladies and gentlemen, boys and girls. Now, if you people want to join our Telegram channel, this is the link exactly. Okay, we put up the notes every single day in this Telegram channel only. And next is, if you people want to learn from the top educators of the country, this is the only way you can learn from the top educators of the country. Okay, join it as soon as possible. Okay, join it as soon as possible. Understand? Take this plus subscription. Okay, you'll be having live classes every single day, weekly tests, structured courses, unlimited access. Okay, and this personal guidance, test analysis, experts guidelines, study material, and the study planners as well. In this Iconic, you'll be getting basically all the benefits you get in Plus. Okay, yes, yes. So next we have, this is basically what you can use my code Yawar in order to get the maximum possible discount. These are the prices for Plus. These are the prices for Iconic. Okay, you can take it for 24 months, 18 months, 12 months, 6 months, 24 months, 18 months, 12 months, 6 months, 3 months. Okay, definitely you can check it out from the screen itself. Now, if you find any of my content as inappropriate, you can definitely report. Okay, the link is in the description below. And thank you so much, ladies and gentlemen. It was all about today. Okay, okay. Okay, I'm Art Coffee is here. So thank you so much, people. See you guys very soon. And it was all about today. Till then, bye-bye. Take care. Thank you so much. Okay. Make sure you subscribe to the channel and hit the bell notification.